Welcome back, everybody. In this video, we're starting chapter 3. As always, when we start a chapter, it's a good idea to look ahead and see what it is that we're getting into before we get into it. So chapter 3 is about describing, exploring, and comparing data. There are 3 sections in this chapter only, but they're all kind of important. In the past chapter, we were looking at how we could describe data visually, basically, by coming up with frequency distributions and histograms and stuff like that to describe data. This chapter continues our look at describing data, but the focus is more on coming up with numerical measures that describe the data in some way. Section 3.1 is on measures of center, which looks at ways of describing where the middle of a set of data is. As students, you're most familiar with the average, test averages and so forth, as a measure of the middle of a data set. We'll also look at some other measures like the median and the mode and then a couple of others. In section 3.2, we look at a measure of how, or a couple of measures of how spread out a data set is or how variable it is. And then in section 3.3, it says measures of relative standing and box plots. So the measures of relative standing are basically about things such as percentiles, which are ways of describing how one data value compares to the rest of a set of data values. And then box plots are another visual representation that uses some of the values that we've calculated throughout the chapter. All right, so let's go ahead and get started with measures of center. So this first part, there's a fair amount of definition-like stuff, so we'll want to be kind of careful with all of it. A measure of center is basically the value at the center or middle of a data set. And the value at the middle, or what the measure of center is, either may or may not be an actual value from the data set. The first thing we're looking at is the average. What we think of as the average is also called the mean. And it's calculated in the following way. It's the sum of all the data values you have divided by how many values there are. And we have a special symbol for that. This thing that looks kind of like a sideways capital M almost is a capital Greek letter sigma, and it's their capital S, like S for sum. And the way to read that is just, we're adding up all the x's. So read that sigma sign as add them up. So we're adding up all the x values, and then we're dividing by how many values we have. And that's how you calculate the mean or average for a data set. Depending on whether we're figuring out a mean for a population or a sample, there are 2 different symbols. If you're finding out the mean for a population, it is going to be this symbol, which looks a little like a cursive U kind of, a lowercase cursive U, but it's actually a Greek letter mu, and it's kind of their little m. And that's the symbol for a population mean. If you're taking a sample mean, then the symbol is X with a little bar on top. Okay, and we say that out loud as X bar, or the sample mean. Okay, remember that what we're doing a lot of the time is we don't know the facts about an entire population. So we take a sample to tell us some idea about the population. And so the idea or the assumption is that the sample mean should be something close to the population mean, right? So X bar is, we hope, a good approximator of mu, is a way you could say that. Okay, couple of notes about the mean. The mean uses every data value. You need every data value in either the population or sample, depending on which mean you're calculating, in order to calculate the mean. Sample means drawn from the same population tend to vary less than other measures of center. What we mean by that is this. If we were interested in, let's say, the average heights of COD students, let's just say, and we were going to take samples of size 30 from all the COD students and calculate the means of those samples, we could make a histogram of the means of the sets of 30 students, and how variable those means would be less in comparison to other measures of center, like the mode or the median that we haven't gotten to yet. Okay, the mean is what's called sensitive to outliers. What an outlier is a data value that is kind of outside the range of most of the data values that we have. So when we say that it's sensitive to outliers, that means that if we have one or a couple of values that are outside the range of the bulk of the values we have, then that's going to greatly affect the mean. Here is an example kind of towards your right. Here we have values 2, 5, 10, 12, and 13 at first. And then for the next two data sets, I've kept the first four values the same, but we've made the largest value 33 and then 133. 4 out of 5 values in the data set have stayed the same, but notice that the mean gets really different really fast, right? The mean of the original data set is 8.4, and that seems like it's, well, it's bigger than 2 out of 5 values, right? The next one, 12.4, is not really in the center of the data set anymore, right? It's bigger than 4 out of 5 of the data values. And then the last one, 32.4, is almost as big as the very last value, not the very last. It's almost, it's still halfway between the fourth and fifth value. Not halfway, but it's in between the fourth and fifth value. The point is that introduction of outliers there is going to greatly affect the calculation of the mean. So that's an important thing to be aware of. Okay, a couple of more examples. In this part, we've got on the left 5 weeks of Amazon opens, the stock price for Amazon back in 2016. What I had done was just add up the values and then divide by 5 because there were 5 weeks worth of opening prices. And that worked out to be $770.28. Okay, for the next example, or the illustration on the right shows how I'd calculated that. I'd used R, which is another statistical software, to help get the calculation done. R is a useful tool for doing statistical and other calculations. It's not in common use. Well, it is in common use, but only in certain circles. Because some people find it difficult to work with. You won't need to have access or use R for this class, but you may run across people who do use it. All right, another example, 6 hourly employees. Our 6 employees have hourly rates of $16 an hour, $16 an hour, then 18 twice, 20, and then 56. We're going to find the mean hourly rate. So how you do this, of course, is we're going to add up the values we have. So there's a pair of 16s, and then a pair of 18s, and then a 20, and then a 56. So we're going to add up the values, 16, 16, 18, 18, 20, and 56, and divide by the number of numbers we have, which is 6. All right, so I've gone through the calculation. It works out that the mean is $24 an hour. So this is another example that illustrates how the mean is sensitive to outliers. Suppose that you are interviewing with a position, a new job at a small company that has 6 employees, or at least in this area, they have 6 employees. And the person hiring you says, okay, well, the average person in this department makes $24 an hour. So you might get the idea that the pay is around $24 an hour. But the thing is that 5 out of 6 people make under $20 or less. The one person, maybe it's a shift leader or a manager or something, makes $56 an hour. The presence of the one person making $56 an hour pulls up the average into the 24 range, where it would be more fair to say that the typical pay that somebody makes is under 20 or 20 or less. It looks like most people make about 17, right? If we take the average of the 16s and 18s, we get 17. That sounds more typical than the 24 does. All right, so next we're going to take a look at another measure of center called the median. And the median is a measure of center that is physically the middle data value of a data set if there's an odd number of data values. If there's an even number, we'll talk about it. And in order to do this, if you think about it, the data has to be sorted, right? If the data is in random order, we're not going to get a consistent answer as to which one is in the middle. The symbol for the median is an X with a tilde on top, or a little squiggle on top, and that's the symbol for the median. And we'll use that for both the population and the sample. We don't have a separate symbol. We're not going to use a separate symbol for that. How you calculate the median is if there's an odd number of values, you just take the middle one. So here I've started with a set of numbers and they're sorted. So there are 1, 2, 3, 4, 5, 6, 7 numbers. That's an odd number of numbers. And so the median should be the fourth value. So here it's going to be 17. Notice that there are 3 values smaller than that and 3 values larger than that. The median is a measure of the center. Okay. If the number of data values is even, then the median is going to be the mean of the 2 values that would be on either side of where you would expect that median to be. So let's take a look at this first set. There's 1, 2, 3, 4, 5, 6, 7 numbers. Okay, so the median is the middle number. That's 21. There's 3 values above and 3 values below. 21 is our median. Okay, so next, we have 1, 2, 3, 4, 5, 6, 7. There's 7 again. I have the same one in there twice. Median still 21. But you'll notice what's different about these 2 data sets is that the biggest value in the first data set was 49. In the second data set, it was 167. But the median stayed the same. So this suggests, or as an example, illustrating that the median is not sensitive to outliers. We saw that the mean was really sensitive to outliers. The median's not. If you change a value, one value in this data set, it's not likely to change what the median is. Okay, so here we are with an even number of numbers, 12, 15, 17, 20, 30, and 49. There are 6 numbers here. So I would expect the median to fall right between 17 and 20. So this is where we're going to take a look at item 2 above. If the number of values is even, the median is the mean of the 2 middle values. So halfway between 17 and 20, we'll take 17 plus 20 and divide by 2. That's 18.5. Another way to think of that, of course, is that the difference between 17 and 20 is 3. Half of 3 is 1.5. So 17 plus 1.5 would be 18.5. Okay, as we saw, the median isn't sensitive to outliers, so we'd say instead that it is resistant to outliers. The median doesn't use all the data values, so you saw that in order to calculate the median, we didn't actually use any of the values except in the case where there was an even number. When there's an odd number of numbers, all we need to know is where the middle is. Okay, in any case, here we could change these 12s into like 9s. The 15s could become 15.8s, and it's not going to affect what the median is. We don't use all the data values to calculate the median. We do need the data values to be sorted, though. If you think about it, that's important. Okay. The last measure of center that we're going to look at right now is called the mode. The mode of a data set is the value that occurs with the greatest frequency. The mode is used not as much with quantitative data, where we might be more likely to use the mean or the median, but for categorical data, we can't really do like math on eye colors or political parties or people's zip codes. Right? So instead, the mode is useful. And there we're just counting or calculating the most frequently occurring values. Okay, a data set can have one mode, it can have more than one mode, or it can have no mode at all. When 2 data values occur with the same greatest frequency, that is, they're tied for number 1, then the data set is called bimodal. If there's more than 2 modes, then we would just say it's multimodal. If there's several data values, each with the same greatest frequency, multimodal. If there's no repeated data values, then there is no mode. Okay, so let's try each of these. So 2, 5, 5, 6, and 10, the mode is going to be 5. 5 occurs more often than any other. Going down next, we have 3 and 3, 5, 8 and 8, 9 and 10. So here, this one is bimodal. There's 3 and 8 are our 2 modes. For the next one, we have 1, 2, 6, 11, and 13. So this one, there's no mode. For the last one, I'm seeing 2s, 6s, and 10s all occurring 3 times. So it looks like this one is multimodal. There are 3 modes, 2, 6, and 10. The mode is useful when we're interested in basically what is the most frequently occurring number, and especially if it's about a set of categorical data. For example, let's say that you work in a department store that sells jeans or something, and you're in charge of ordering jeans. You probably want to make sure that you had plenty of the sizes that occur the most, right? If you know that 32s occur most frequently, right, it's not going to be sufficient to order a bunch of 31 and 33 waists, let's say. You want to know which one is the most frequently occurring value, and that would involve the mode. Okay, one more measure of center. This one is much less frequently used. This one is the mid-range. The mid-range of a data set is the measure of the center that is the value midway between the maximum and minimum values. So notice that this isn't the middle of the data set in the sense of like the median is the middle, physical middle of the data set. This is the mean of the highest and lowest value. So formulas down below. There's no symbol for it that we use, just the word mid-range. Maximum data value plus the minimum data value divided by 2. So here, for this data set, 5, 10, 12, 17, 20, and 25, we would take 25 plus 5 and divide by 2. That's 15. So that would be the mid-range. Okay, just to review, the median would be the value halfway between the two of the middle values, that is halfway between 12 and 17. So we'll take the mean of 12 and 17. 12 plus 17, that's 29. 29 divided by 2 is 14.5. So that would be the median. Notice that the median is not the same as the mid-range. In this case, they're close, but that's not necessarily going to always happen. Okay, some important properties of the mid-range. Because it uses just the maximum and minimum, it's very sensitive to outliers. That should be pretty obvious. If I go back to this data set and turn this 25 into 250, then that's going to hugely affect our mid-range. So let's take a second and see what that would be if it was. 250 plus 5 is 255. That's 127.5, right, would be the mid-range. Okay, and that's bigger than almost all the values, right? So not a very good measure of center in that way. So very sensitive to outliers. Okay. Mid-range is not used all that often, but it does have a couple of nice features. It's really easy to calculate. Okay, you only need 2 data values to do it. If I give you, 100, people's heights, it's still not going to take you very long to calculate the mid-range, provided that you can tell at a glance which one is the biggest and which is the smallest. Easy to calculate. It does help reinforce the point that there are several ways of calculating the center of a data set. It's often used incorrectly for the median. People frequently confuse the median with the mid-range, so you want to be careful not to do that. The mid-range is the sum of the biggest and smallest values. The median is the physical middle of the data set, okay? And it does involve calculating a mean when there are an even number of values, but that mean is the mean of the 2 kind of middle values in the data set. Mid-range is the mean of the biggest and smallest. Okay, so just to make sure we've got this, we're going to find the mean, median, mode, and mid-range for this data set. So at this point, you want to pause the video and try this on your own, and then we'll see what we get. All right, so let's get started. Let me start with the mean. So that would be 2 plus 3 plus 5 plus 5 plus 10 plus 12. So that's 20, 32, 34, 37 divided by 6. And then I can give you a decimal for that. Looks like 6.2 just about. Okay. And then the median is easy to calculate here. The data values are sorted. And so the middle value is halfway between 5 and 5, which is 5, right? So there's that. For the mode, the most frequently occurring value, it looks like 5. 5 occurs twice and nothing else does. For mid-range, we want the sum of the largest and smallest values divided by 2. So 2 plus 12 divided by 2. That's 2 plus 12 is 14 divided by 2 is 7. So the mid-range is 7. So there's 3 different measures or 3 different values for the middle, depending on how you want to calculate it. Okay. We have some rules about how to round values here for the measures of center. For mean, median, and mid-range, you use 1 more decimal place than is present in the original data set. So here the data values were all whole numbers, which is why the mean, I gave it out to 1 decimal place, okay? On my calculator, it said like 6.1666 something or other. So I rounded it to the nearest 10th. If our data values had 1 digit behind the decimal point, then my answers would have 2 digits behind the decimal point. Okay, so 1 more decimal place than is present in the original values. For the mode, don't round anything. Okay, the values of the mode are actually data values, right? The others need not be, but the mode is actually a data value. It's the most frequently occurring data value. So you're not going to round anything there. In your calculations in general for this class from now until the end of the term, try to avoid rounding intermediate results, okay? So here that was not really an issue, but just in general for the future, try to avoid rounding intermediate results. All right, that will take us to the end of this part of 3.1. In the next part, we're going to look at how we can calculate some of these things for grouped data. In the meantime, let me know if you have any questions and have a great day.